there's one very small add-in we're going to put with our progression sheets today, and it deals with this problem. So you're given A, B, and B, C are perpendicular to one another. When we did that, we would write, excuse me, we wrote down in our progression sheets, we would state the right angles that are formed, then we would say that right angles are congruent to right angles, and so on and so on. In this instance here, where A, B, and B, C are perpendicular, we just have one right angle being created. Everybody see that? Just the one right angle. All right. So what they're doing here is the books tend to do double givens, which is fine. So this one was technically the given below it as well. There should be like two parts. Now, why is angle ABC a right angle? Definition of, it's not parallel, perpendicular, because what's given to you? Perpendicular. So what do you say? Definition of perpendicular. Don't make things up, guys. Don't make things up. Now, one of the things I want you guys to add into on your progression sheet is maybe make a small note about where you have right angles. Where you have right angles, put in there, sometimes you can write angle equals 90 degrees. Remember how we wrote if you have right angles, you say right angle congruent to right angle? And sometimes you might have to say that the right angle itself is 90 degrees. This is one of those cases. So it's not a bad idea to have that there as well. Also, we had a student in 910 that asked for larger squares for the progression sheets. And so what I did today is I made a quick little, instead of the 3x4s, I did 3x3s. One of the best ways to prepare and study for quizzes or tests that have proofs is to rewrite your progression sheets. Reason being is that when you write something down, you're going to kind of remember where you put it on the sheet. Maybe put all of your segment stuffs in the first bunch. Then put all your angle stuffs after it, so on and so on. I would highly, highly, highly suggest rewriting your progression sheet at some point in the next few days. Yes, ma'am. Yes, ma'am. So also, it helps, even though if you have them, you got to know where they are. And if you rewrite it, it'll help you remember where you put it. So I'm going to pass you guys out a larger sheet. If you want it, great, use it. If you're fine with what you have, that's fine as well. But I know that a couple people had asked for larger sheets. I give up counting. All right. Anyway, so go back to the next statement here. It says that you have ABC is 90 degrees. Reason why it's 90 degrees is look at what was stated beforehand. You said that you had a right angle. I don't know if you guys have caught on to this yet, but a lot of things you say on the left is repeated on the right as a definition. So even if you have absolutely no idea what you're doing, you could probably guess what you have to do. Definition of a right angle. Right? So now let's take a guess of why angle ABC is made up of angles 1 and 2. Very good. If you look back at your diagram, a lot of times you have to go back and forth to the diagram to figure out what were they coming up with. Why did they say something? Well, in this case, if you look at your diagram, it says that angle ABC is made up of angles 1 and 2. Sometimes they do that so you don't have to have extra letters. So that's just angle addition, just like you said. So, excuse me. We know that angle ABC equals 90, and angle ABC equals 1 plus 2. So why does angle 1 plus 2 equal 90? Substitution. Very good. Remember, if you can't figure out what happens, look back above. Anytime you see something replicated, and then the two things that are equal to it, are set equal to each other, that's a dead giveaway if you have substitution. And then last but not least, what changed between 1 and 2, angles 1 and 2 equaling 90, to angles 1 and 3 equaling 90? You substitution again because you put 3 in for 2. Because we know that up top, 2 and 3 were the same. Okay. As you're doing these, this is as complex as this stuff gets. We don't know how to do anything else yet, except a little quick add, subtract, maybe some multiply, complementary, supplementary, just some rewrites. Okay. A lot of angle addition, segment addition, midpoints, things like that. Okay. Then the other one had a very slight variation. It has a step that we no longer deem necessary. So if you couldn't figure out this one step, that's fine. I wasn't going to require that you guys have to do it. But to start out with, why are angles 1 and 2 a linear pair, and angle 2 plus 3 plus angle 4 equal 180? Given. Okay. These two steps were given. Now, this step, part B, is erroneous. We don't need it. It's not erroneous. It's extraneous. Extraneous. That's why I teach math. Erroneous? Hey, you got the Google. What's erroneous? You guys all have phones out. Erroneous. Erroneous. Erroneous? Not erroneous. Erroneous.
I'll do it right now. What is erroneous? Error is an action.
All right, here's what I got.
An error is an action which is inaccurate or incorrect. Okay.
This means you have to know how to spell the word erroneous.
It's an E on. I would have
Oh, is it his birthday? It is? I think we need to sing. All right, we need to sing and we gotta make it back. No, we don't want to punch people for birthdays. All right. Thank you. Wrong or incorrect? Yeah. Okay. I think extraneous is better. So, anyway, back to this. Not that we ever got off topic. What? now you're gonna sing to them. 1, 2, 3, go! Happy birthday, dear. Sorry. Happy birthday. Man, that was awful. Good luck for you. Ah, you can't take it off. You're in the class right now. Does it look? Because you're like wearing a sea hat. You're like you got a sailboat for a hat. That's great, man. That's awesome. Nice enough. Anyway, so back to actually doing math work. One of the things that some of the older textbooks, some of the older things had us do. It was a gift. That was awesome. Anyway, so one of the things that we used to do when we really beat the proofs over your guys' heads, besides putting earphones, was when you had linear pair. Remember how yesterday we did perpendicular, then we said state the right angles, then state the right angles were congruent. We gave 2 steps to that. We used to do that also with linear pair. We would force you guys to go linear pair, supplementary, add to 180. We got rid of the supplementary step in that one because saving space. So I won't ask you guys, or I won't put that in if there's ever a fill in the blank. I won't make you guys have to write out this supplementary part because according to our progression sheet from what we did yesterday, we went from linear pair to saying that 2 angles add up to 180. So if I go to angles 1 and 2, why do these 2 guys add up to 180? By what definition? The one that has a word to it. Okay. Now, the next step is a little bit weird because they had spaced oddly. If you move this up here, angle 1, angle 2 plus angle 3 plus angle 4. This is one of the reasons why I wanted you guys to write this one out fully by hand. So that way when you wrote that, you would have seen that you've got 2 things that equal each other now. Well, the reason those 2 things equal each other is because both of those things have to equal 180. So via what rule can we set those 2 equal to each other? On D. And then lastly, if you wrote this out by yourselves, you would have recognized that you had the same thing on both sides of the equal sign, which means what would you do? Subtract. Yep. Okay. Now, it wasn't, again, we keep trying to get you guys to realize that we're not trying to make these things super tough. It should be real quick and painless. Okay? We've got 2 more to do. We'll get you those. But first, we need autographs.
Oh my God. Dad, why am I the only one that paper people? Come on. Apparently she's not good at pictures.
Or she's just not in this class. It's gotta be in the white.
Yeah, you're actually.
Or just change your color.
Wait, I'm just gonna send this shit.
Or you can, how about this? Move the picture to the left a little bit.
But it's like.
That's fine.
Okay, bye now, your last name.
I don't know.
Wow, that's not. It would be a lot funnier if you would have hit her in the head. I see the hands moved out, yeah. Might as well hit the next one.
Next.
The right arrow. That's the same thing. Yeah, now hit the little red X.
Right, this
All right.
corner. What? Oh, gotcha. Again? Lord.
How do you guys not call it?
We did call it back.
Yeah. You were backing her up.
She actually passed it, Mommy.
Exactly.
Other stats are passing.
Yeah. Okay.
Why not now? I think the only thing that was different from when I was typing that in, I think I couldn't say parcel of the picture beforehand. I forgot to email this one to myself this morning, so I didn't get it right away. I hope I didn't miss something. I promise. Ladies and gentlemen, come on down. Like we were saying, we've got a couple left to go today. Then we have 4 fill in the blanks for tonight.
Hey.
Then after that, tomorrow we'll and tomorrow we'll do a handful in class that are on your own. And then we'll be ready for our quiz competition. You guys have all the progressions, there's nothing left to pass, it's a matter of getting these things straight.
We're going through these ones now, you don't need to put the.
Yeah, make sure your progression sheet's out so you can verify what's
Yeah,
going on.
progression sheet and the sheet we just passed out. You guys will need those to go through now. The homework will come after. Alright, so the first one, I don't think they're labeled, so look at the one that has this, make sure you're looking at the right side of the paper. And the first statement should be angle ABC is congruent to angle DEF. Everyone on the right side? Alright, so why is angle ABC congruent to angle DEF? Yep, good. Given. And why is angle 2 congruent to angle 4? Yep, good. So we have 2 things given this time. So when you work through these, you want to look at what's given. So now we've done that. And now how can we use what's given? So now it says angle ABC is equal to angle DEF. Yep, that's definition of congruency. You can see the congruent sign just switched to the equal sign. So that's how we use that given statement. And then similarly, it says angle 2 is equal to angle 4. And what's our reasoning for that? Good. So now we've taken both of our givens, used what our progression sheet says we can do with them. Now the next step is a little trickier. So it says angle 1 plus angle 2 is equal to angle ABC. So if you want to look back up at the diagram, it can help you. You got it. You're good. So here it's saying angle 1 and angle 2. If you add them together, then you're getting angle ABC. So that's coming from the diagram there. And she's right. So that's. Is it do you guys write it as property of angle addition or just angle?
It's angle addition, it's fine. Yeah. We try to keep it from being too wordy.
Right, and then it says angle 3 plus angle 4 equals angle DEF. Yep, so angle addition again, because you can see angle 3 and angle 4 add together to be angle DEF. Okay, now angle 1 plus angle 2 is equal to angle 3 plus angle 4. Does everyone see where that's coming from? If you don't know, like Mr. Murphy said, look above. So here we have angle 1 and angle 2 are both how did we substitute that? What? Oh, there we go. And then angle 1 plus angle 2 is equal to angle 3 plus angle 4. Good substitution again. Alright, now you notice you have the same things on both sides of the equal sign, so what are you going to do? Yep, so subtraction property of equality minus prop. And then last step here, it says angle 1 is congruent to angle 2, or angle 3. So what property is that? Good.
Have you guys figured out that when you're looking at these, even though there was no progression to this, have you noticed that when things just get rewritten a lot of times, it's substitution? A lot of it. When you see two angles added together to equal another angle, if it's usually the first time that that's written, that's usually angle addition. Same thing happened with segments. When we had the first time we wrote down two segments adding to equal a different segment, it was usually segment addition. There's certain patterns to all of these. You may not understand what the hell is going on all the time with it, but if you take a good guess, you're probably going to be right. Seriously. Trust yourself. Just take a guess.
All right, does everyone have that down? One more. We're gonna flip your pages over. We're looking at this one now. So it says BD is perpendicular to BA. Angle 2 and angle 3 are complementary.
This is why I forgot that when I pasted that back in the 2 plus 3 sheet.
Where? Fourth step?
Yeah. Here's the sheet. When I was cutting and pasting, that one just disappeared. It was, for some reason, this was 90, and then this one was what? 1 and 2 was ABD? Or no, I'm sorry, 2 and 3. Sorry about that. I remember those being mixed up.
All right, so reasoning for BD perpendicular to BA. Given. All right, this one's set up a little bit differently because you're not just going to state both givens right away. Instead, you're going to take that given and look at your proof progression sheet and then decide what statement you can make based off of that given. So look for that where I think you guys have heard yesterday it should be about perpendicular. What happens when you're giving two things perpendicular to each other? Yep. So angle ABC is a right angle by the definition of perpendicular angles. And then perpendicular angles was that one that had two statements that you could make. So now that we've said that it's a right angle by the definition of perpendicular angles, what's the next statement we can make? No, so that angle ABD is 90 degrees. Look at your proof progression sheet. Why can we say that angle ABD is 90 degrees? Yep, definition of right angle. So remember, when you have perpendicular, then there's two statements that we can make. Okay? And now we have angle 2 and angle 3 are complementary. Why are angle 2 and angle 3 complementary? Good, it's given. So now you want to look at your proof progression sheet. And what does it say? What statement can we make when we know that we have complementary angles? Well, it says angle 2 and angle 3 is equal to 90 degrees. And what's our reasoning from that proof progression sheet? Now look at your proof progression sheet. What's the reason we can say? And remember, look above. We're often going to use the words that it says right there. Yep, so it is 90 degrees, but it's 90 degrees because definition of complementary angles. So look at your given, find it on your proof progression sheet, and then you would find definition complementary angles. Okay, now we've taken both of our givens and come up with what we could. Use both of our statements there. So now it says angle 2 plus angle 3 is equal to angle ABD. Yeah, why do you need substitution?
sometimes you have to go back and look at the pictures and see what you were doing. Why do you have two things that equal 90 instead of equal to each other?
Yeah, so if you look at this one, what he was saying here, so you have measure above, you have the measure or angle 2 and angle 3 add to 90, and you have angle ABD adds to 90. So since both of these are adding to 90, they're just taking these two left sides and setting them together. So there we have substitution. And then it says angle 1 plus angle 2 is equal to angle ABD. Huh? It's actually going to be angle addition. Because if you go back and look at that top, if you go back and look at your picture, you have angle 1 and angle 2. You add those together, and you have angle ABD. Does everyone see that? So for that one, you had to go back up to the picture to see why they were doing that. Do you think there's a way you substituted to have angle 1 and angle 2? But we haven't done anything with angle 1 yet. So if you haven't seen it yet above, then try going to the picture. So there we have angle addition. Now angle 2 plus angle 3 is equal to angle 1 plus angle 2. Good, substitution. So now we took those two steps. We had both of them equal to angle ABD on the right, so we took the lefts and set them equal to each other. All right. So now you have 2's on the left, 2 on the left side, and angle 2 on the right side. Yep. So we're going to subtract those 2's off of both sides. So minus prop equals. And last step there, so angle 3 equals angle 1 is switched to angle 3 is congruent to angle 1. So, yeah, definition of congruence. Does anyone have any questions on any of those steps? Yeah. Yeah, so do you remember on the last problem, I don't think we did it here. On this last problem, we switched from congruence to equal here, and it was still definition of congruence. So it's the same, what's that term, like reflexive, it's the same both ways, whether it's congruence. You guys good on these?
So here's the other ones that we wanted to start on, and we actually have a little bit of time, so it'll work out well. That we should be able to get at least the first one done while we're in here, and we'll still be able to go over it together to make sure you got it correct. What's that? Yeah, I'll get it. So, ladies and gentlemen, on this sheet here, the one that we're seeing is the first one, is the one that says the midpoints. Okay? The one that says the midpoints, that'll be the first one. You'll notice that I tried my best to add in a couple extra lines to show how they were separating the steps a little bit. But let's take the first 5 minutes or so, because we've still got 10. Work on this one by ourselves, and then we'll go over it in about 5 minutes and see how that you're setting it up the right way. Yes, ma'am. The one that has midpoints at the beginning. I think it's the very first one. I don't think the other. I think it's the only one that has midpoints. Okay. We'll do that. I'm gonna go get her pictures, and we'll check them in about 5 minutes. Yeah, bud. Yeah, grab an eraser. We were doing the. Sorry, this is loading up slowly. Oh, Oh, was I recording that? Oh, I was. That's right. Feel free to screenshot that, ladies and gentlemen. Anyway, M is the midpoint of AB. Why is that? It's given. B is the midpoint. These are both given. Now, every time that we do given statements, you want to go to the diagram and use the progression. I know that M is the midpoint of AB, so that means these two have to be the same. Well, good thing I wrote that down there because of the definition of a midpoint. Hey, again, since B is the midpoint of MD, oh, that has to be the same. Oh, look at that. Definition of a midpoint. Again, go to the diagram. Some of you guys did this. You went to the diagram, you saw that you had MD, and you drew that. That MD is made up of those two smaller segments, which means you used segment addition. What changed between those two? Substitution. Very good. Very good. Now remember, anytime you go from repeated addition to multiplication, just definition of multiplication. Yes, sir. All right. So finish out the last three of these. Oh, the next one. There's something on there that says LS equals itself. Okay. That's called the reflexive property. You are always equal to yourself. We talked about that in our progression sheets when we said look for a shared side. Sometimes you have to define that. So in that proof on number 2, I even put a hint of that on the calendar. That's the reflexive property when you're equal to yourself. It is LS, isn't it? Yeah, LS equals LS. That's the reflexive property. We'll talk more about that one tomorrow. From there. There's a reason why you have to define it before you can add it. No, Friday. Yeah. What's that? I should, yeah, unless I'm dead. Yeah. No, unfortunately, I won't be around today. I'll be down at Huntley. Yeah, I should be around. I don't know. Unless I'm dead, I don't plan on being.